Our last example, we're going to have a part A through E. So we're going to be doing all of this 5 times. Let's put everything together. Your function, domain, range, symmetry, and even in a bonus intercept question. So determine whether or not the graph is that of a function by using the vertical line test. So we'll say yes or no here. In either case, use the graph to find the domain and range, the intercepts, if any, and then indicate whether the graph is symmetric with respect to the x-axis, y-axis, or origin. Okay, so is this a function? Does it meet the vertical line test? Anywhere you put a vertical line, it only intersects once, which means that x does not repeat. So is this a function? Yes. So domain and range. Domain is my x, and I'm going from left to right. So as I go from the left to the right, the leftmost thing I touch is an arrow, which means negative infinity. And then the last thing I encounter with this graph is also an arrow. So positive infinity. Your range has to do with your y's, and we're going to go from the bottom to the top. So as I go from the bottom, using this edge right here, the first thing I encounter are arrows again. So negative infinity. And then what's the highest y value on this graph? Here it is at 2. And that will have a bracket because it's included. Now, intercepts. This one kind of frustrates me because a lot of us don't know what intercepts are, and we should by the time we get to pre-calc. So, intercepts. Where is it crossing your x and your y axis? I can't tell you how many times you guys will just start giving me the ordered pairs that are on this graph. That is not an intercept. Just because they give you an ordered pair does not mean that's an intercept. Where is it crossing the x-axis? So here is my x-axis here. Let me erase these circles. Where is it crossing this x-axis? It's crossing right here at -3, 0. And it's crossing right here at 3, 0. And where is this crossing your y-axis at? It is crossing right here at 0, 2. Those are your intercepts. Where is it crossing in the x-axis and the y-axis? So we have -3, 0, 0, 2, and 3, 0. Okay, when you have an intercept, one of those numbers should be a 0 in that ordered pair. And just a little tidbit, in my math lab, you do have to put a comma in between all those ordered pairs, or you'll get it wrong. So heads up there. And then symmetry. Do we have any kind of symmetry here? So starting with x-axis, is it reflective over this x-axis? Does the top look the same as the bottom? No. What about along the y? If I use this as a mirror, does this left side look the same as this right side? And yes, it does. So we have symmetry with respect to the y-axis here. And then check also origin. If you flip this upside down, that does not look the same. So now these arrows are pointing up, and here they were pointing down. So this is the only type of symmetry that we have. Okay, let's keep going. I want to emphasize that domain and range is what I really want to make sure that we are getting good at. So part B, we have this graph here. For my people that have taken trig, you should recognize this. This graph is the graph of sine x. And if you haven't taken trig yet, you're going to start graphing these here soon. So is this a function? Does it pass the vertical line test? Yes. What is the domain? So as we go from left to right, the leftmost is right here at negative pi. And then it's going to go all the way here to pi. What is the range? Using this edge here, this top edge, as we go up, here's where I first encounter my graph. And what is that y value associated with it? That's at -1. And then as you go up, the highest y value is right here at 1. Okay, how many intercepts do I have? I have an intercept here at -pi0 at the origin. So that would be considered an x and y intercept. And at pi0. Okay, that is where it's crossing that x-axis and that y-axis. So symmetry. Is this reflective across the x? Does the top mirror the bottom? Well, now you can see a swoop down here and a swoop over here, so that's not the same. How about along that y-axis? Is the left mirroring the right? Nope, again, swoop down here, swoop up here, so it's not origin. But when I flip this upside down, does that look the exact same? Yes, it does. So this is symmetry with respect to the origin. Okay, let's try doing C together, and then I want you guys to try to pause and do D together, or D by yourself. So let's do C together one more time, and then I want you to try to pause before we go through D. So C, is this a function? Anywhere you put that vertical line, it's going to intersect twice. So this is not, I'm just going to put no, that is not a function. So domain. As I go from the left to the right, the first thing I encounter are arrows. So that is -infinity. 2, last thing I encounter are arrows, positive infinity. Notice with arrows, you're going to have some infinities. On this one, I had no arrows. I had a starting point and an ending point. So my domain had a definite start and end. My range had a very clear start and end. But when I have arrows, I'm going to have some infinities in there. Okay, my range. Now my range can be a little bit tricky here. Using this edge right here, as I go from the bottom to the top, the first thing I encounter are arrows. So we have -infinity. And then we have a break. It goes all the way up to -1. And then as I go up, I have no y values right here in the middle. So it goes from -infinity to 1, or -1 with a bracket. So then I have a break right here in my range where I have no y values. I still have x values, but no y's. And then it picks up again right here at 1 and goes to arrows infinity. And then because I have 2 different sections here, I'll put that union in between. Now, intersects. Does it cross this x-axis? Nope. So I don't have any x-intercepts. But how about on this y-axis? Does it cross? Yes. Crosses here and here on that y. So that is at, what would that be at? 0, 1, and 0, -1. Okay, symmetry. Starting with x, does it reflect across this x-axis? Yes. The top is the same as the bottom. Put in a line right here. The top mirrors the bottom. So we have symmetry with respect to the x-axis. We are not done though. You have to check all of your types of symmetry here. Is it symmetric with respect to that Y? So I know I was getting a little crazy with my different highlighter colors, but look at the left and the right. Does this left side mirror this right side? Yes, it does. That looks the same as that side. So it's also symmetric with respect to the y-axis. And then how about when I turn it around? If I turn it upside down, does that look the exact same? Yes. So this is also symmetric with respect to the origin. This one has all three types of symmetry. So when you find one, don't just assume you're done. It could have one type, two types, or all three, or it could have none as well. So you have to look for all of them at every problem. Okay, I want you to pause this video and see if you can do D on your own. All right, I hope you had time to pause. So let's check your answers here. We should have got no, this is not a function, because as you put a vertical line, it's going to intersect in two different places. Your domain, as you go from left to right, the leftmost, we get arrows, meaning negative infinity. And then the rightmost, we get 0. After 0, we have no more graph right here, so it ends at 0. My range, as I go from the bottom to the top, the first thing I encounter is an arrow. The last thing I encounter is an arrow. So negative and positive infinity. My intercept is only at 0, 0. It doesn't cross anywhere else on the X or anywhere else on the Y, just right here at the origin. And then lastly, we have symmetry with respect to the X-axis, because on that X-axis, the top of it mirrors the bottom. Now let's do E together. And I don't love E because we haven't really gone over types of graphs like these. We can't, so you can see that this looks like it's from a graphing calculator, and you're going to have one like it in MyMathLab that looks very similar. It looks like a screenshot from a graphing calculator. We kind of need to know that these all have arrows on the ends of these. And we have something called horizontal and vertical asymptotes. So here I have a vertical asymptote, which I'm going to represent by VA. Vertical asymptote at X equals 0. And then we have a horizontal asymptote on that X-axis. Right here also at Y equals 0. And this one's a horizontal asymptote. Now we're going to talk more about asymptotes when we get to the beginning of module 3, but until then, we're just going to kind of wing it. So what these asymptotes are is it's a imaginary line on your graph that your actual graph is going to get closer and closer and closer to, but never touch it and never cross it, only approach it. That gap between the asymptote and your graph are going to decrease. They're going to get closer and closer and closer, where it almost looks like it's on it, but it never technically is. Okay. So is this a function? Nope. If you put a vertical line in here, it intersects twice, so it is not a function. What is your domain? As I go from left to right, we encounter kind of these arrows, but what we actually encounter first is that vertical asymptote. So that vertical asymptote is here at X. So as this line goes up, it's going to get closer and closer to this vertical asymptote, which is at X equals 0. And as this one goes down, it's going to get closer and closer to this vertical asymptote, which is again X equals 0. So because the first thing we encounter is that asymptote at 0, our domain starts at 0 with a parenthesis because again, it's never going to touch it. It's never going to cross it. And then as it keeps going, we end with arrows and it's just going to keep going horizontally forever. So to infinity. Your range, as we go from the bottom to the top, it's going to go down forever, meaning it's going to reach all of those numbers. So negative infinity. And then it's going to go up. And even though we go to an arrow, when you go above that, you go to that horizontal asymptote at 0. So as this graph below it goes closer and closer to that asymptote, it's never going to touch that 0. We have 0 with a parenthesis. Then it jumps because it's going to skip over that horizontal asymptote. And then we pick up at this graph again. Again, it's an arrow, but it's on that top portion. It's going to get closer and closer to that line, but not touch it. And then it's going to keep going up forever. So my range is almost negative infinity to infinity. It's skipping over this 0 though, since they're both in parentheses. So it's not included in this solution or this solution. That's the literal one number your range cannot equal because of that horizontal asymptote right there. Again, I'm including this in here because it's a question in your homework. So if you struggle with your homework question that's on this one, or really any of them, right? But specifically this one, please email me and let me help you because we haven't really gone over asymptotes. So I don't love this question, but it is in your homework. So then intercepts, we have none because it is not going to touch this vertical asymptote. And it's not going to touch this horizontal asymptote. And those are both on the X and Y axis. So it doesn't have any. And then symmetry. Does it have x-axis symmetry? Does the top mirror the bottom? Yes, right here, this top mirrors the bottom. So we have symmetry with respect to the x-axis. Do we have y-axis symmetry? Nope, the left has none. The right has some stuff, so it's not the same on both sides. And then if you flip it, that is not the same because now these graphs are on the left side and they started on the right side here. So just symmetry with respect to the X. And I don't have any examples as part of example 6 where you don't have any type of symmetry, but that is also possible, right? So you can have one, you can have all three, you could have 2 different types. An example of it having none would be example 2, this quadratic right here. You can see here's my x-axis, so the top does not mirror the bottom. My y-axis, the left does not mirror the right. And this is a parabola opening up. If you rotate your paper 180 degrees, now this is a parabola opening down. So example 2, part B, would be an example of having no type of symmetry. And so that is possible as well.